Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform, a chemistry lesson. If you remember in the previous lesson, we discussed, or we first of all came up with the objectives which you need to achieve by the end of this chapter. And also, we defined two important terms which we will be using throughout in this chapter. We talked about law and gas, where we say that a gas is a physical state of matter with a definite mass, with a definite volume, with an indefinite volume and indefinite shape. And the law, we said that it is a fact, it is a statement of fact, which is coming from an observation, from an experiment you've done on natural or scientific phenomenon, which occurs due to changes in some conditions, which again we are going to discuss them further in this topic. In our today's lesson, we will start with Boyle's law, because we talked about the four laws, which were Boyle's law, Charles' law, combined gas law, and Graham's law of diffusion. So we start with the first law, which is Boyle's law. So this law was named after a scientist called Robert Boyle. So Robert Boyle was the name of the person who came up with this law, Boyle's law. I want to define this law. Definition. In Boyle's law, state that the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. It states that the volume of a given mass of a gas is inversely proportional to pressure, and temperature must always be constant. The volume of a given mass of a gas is inversely proportional to pressure at constant temperature. I want to simplify it further for you and explain it and say, when we say it is inversely proportional, when we say that the volume of a given mass of a gas is inversely proportional, we mean that when volume, all this means that when volume of a gas increases, the pressure of the gas decreases. The volume of a gas increases, the pressure of the gas decreases. And when pressure of a gas increases, the volume of the gas decreases. The volume of the gas decreases. When volume of a gas increases, the pressure of the gas decreases. And when the pressure of the gas increases, the volume of the gas decreases. That is the simple way of understanding Boyle's law, that when the volume is high, pressure is low. And when pressure is high, volume is low. I can use this example to explain it to you simply or in a simple way. I can use a small container in my container. I have this is just a tube. This is the piston. Inside my tube, there is air inside. So there are particles of air which are inside my tube. When I press this piston downwards, it means, one, the volume decreases. So the volume will go down. The volume of the air particles inside my tube will decrease. And at the same time, pressure increases. I know you're wondering how pressure increases. I will explain it to you. The reason why pressure is increasing is because when you press this piston downwards, the volume decreases. And at the same time, the pressure is increasing because the particles, they are now closer to one another. The particles of this air inside this tube becomes closer to each other, meaning that there is more collisions between these particles themselves. There's more collisions between these particles of this air inside within themselves and also within the walls of this tube. That is what is causing the pressure to increase. So anytime volume decreases, pressure increases. Pressure increases when volume decreases. I hope you get that clearly. At the same time, I want you to imagine if you pull this piston upwards. If you pull this piston upwards, this what means is that the volume inside, because now this the volume inside will increase. The volume of air inside the tube will increase. And the pressure will decrease. And the reason why pressure will decrease is because the particles, they now move far apart from one another. The particles of air move far apart from one another. When they move far apart from one another, then there is the effective collisions or the probability of these particles colliding with one another and also with the walls of the tube decreases. And that's how the pressure decreases when volume increases. I hope you also understand that very clearly, because our Boyle's law, we have said that when the volume of a given mass of a gas, or the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. So temperature always must be constant. So temperature must remain constant at all times. For example, the room temperature, we take the room temperature to be 25 degrees Celsius or 298 Kelvin. That is a constant temperature. So at all time, temperature must be kept constant. There is no variation in temperature. Understand that very well. I will use a live example, and I will use one of my simple apparatus I have. This one is called a dropper. This dropper is having a volume of air inside. There's some air inside this dropper. What happens when I press the upper part? What do you think happens to the volume? The volume is decreasing. And the pressure inside, or the pressure of the particles inside, is increasing. Now to demonstrate that, maybe you can put the dropper on your finger and now press the upper part. When I press the upper part, there's some force exerted on my finger. There's some force exerted on my finger, means that the volume of air inside now is getting its way out, or is trying to get its way outside this dropper, because volume has decreased and pressure, volume has decreased and pressure has increased. That's why that high pressure is now forcing my finger, so that the air can get out. That is a simple demonstration. So it shows that when you decrease volume, pressure increases, and that's why there's some force exerted on my finger. Get that clearly. At the same time, if you release, then it will have, the dropper will have the original shape of the dropper. So there is some air inside at the same time, and there is also pressure, which is inside, because pressure cannot be zero and volume cannot be zero. You cannot have volume of air having zero pressure, and you cannot have pressure when there is no volume again. So volume and pressure cannot be zero. Maybe now to demonstrate it further using a graphical representation, I can draw a simple graph again to explain it to you how when volume increases, pressure decreases, and when pressure increases, volume decreases. I will draw a simple graph to demonstrate that. So this is our y-axis and the x-axis. So this is a graph of pressure against volume. So when you're drawing a graph of pressure against volume, then pressure should be on the y-axis. So we have pressure, which is pressure P, and volume, we have volume V. Now to demonstrate this Boyle's law, then the curve will look like this. That is a curve. Then suppose we have some calibrations, though this ours is not drawn to scale. If you have 0, 10, 20, 30, 40, our scale, and also on the y-axis you have 10, 20, 30, 40, 50, like that. It means that, let's take an example of where the pressure of a gas is at 40. The pressure of a gas is at 40, and at the same time, the volume of this gas is at 10. Pressure is at 40, the volume at 10. Let's take when the volume of this gas is 10, sorry, when the pressure of this gas is 10, we see what the pressure will be. So that is kind of the pressure which will be present. So you see that the pressure is around, let's say it's something like to do with 23 pressure. So this shows you that when the pressure is high, volume will be low. That's why we have the pressure is 40, the volume is 10. And this time we have pressure being 10, the volume has increased. That is the same way I've explained in this one, that if you press the piston downwards, the volume will reduce and the pressure will rise because the particles of this air inside the tube is colliding more within themselves, those particles, and with the walls of the container. And when you pull it upwards, the volume in the tube increases and the pressure decreases because the particles inside, they don't collide more because they are far apart from one another. I hope you understand that very well. So you can explain it using the piston, and also I've used a simple graph to explain the Boyle's law. So this is a graph of pressure against volume to demonstrate Boyle's law. Demonstrate Boyle's law. That is what I wanted you to understand in this lesson. But as I finish, I've said that this law was named after a scientist known as Robert Boyle. And we define this Boyle's law as that the volume of a given mass of a gas, the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. So temperature always must be constant. And the simple way of illustrating this, I've said that when volume increases, then you expect the pressure of the gas inside a certain container or a certain vessel to increase. When the volume increases, you expect the pressure, to decrease. And when pressure increases, then you expect the volume to decrease in that container or in that vessel. Then I've used a simple example of demonstrating that using a container or a tube which is having a piston. And I've seen that when you press the piston downwards, the volume inside decreases and the pressure will increase because there are effective collisions that the particles of this air inside the tube collide more with one another and also with the walls of that tube. And that's why the pressure is increasing. And at the same time, if you pull the piston upwards, the volume inside the tube will increase and the pressure will decrease. And the reason why the pressure is decreasing is because the gas particles or the volume of air inside the tube, the particles are far apart from one another. So the particles are not colliding more fast or move vigorously, and that's why the pressure decreases. That is a simple way of demonstrating Boyle's law. Otherwise, that's the part of our lesson today, and I will leave you with this assignment. And the assignment is I'll give you one question only. Is define Boyle's law. Define Boyle's law. I have defined it for you, so try and see whether you can be able to remember what we have discussed. Thank you for participating in the lesson. See you in the next lesson. Bye.